I'm explaining these in my own words.
Yeah, of course, that's the best. Go on.
Commutative properties are like changing orders.
Okay, that means you swap the numbers or you change the order. Okay.
Yeah. Example, A plus B is equal to B plus A, and B multiplied by A is equal to A multiplied by B.
Okay, very good. So you said that it holds true when it comes to addition and multiplication, right?
Yeah.
Okay, next. So it does not hold true for subtraction and for division, right?
Yeah.
Okay, next.
Distributive properties. Distributive properties are the product of a difference or sum of a number is equal to the sum or difference of the product. Example. Example 16 multiply 10 plus 2 is equal to 16 multiply 10 plus 16 multiply 2.
Very good. Okay. Okay. How about will it hold true if I say 16, let's say 16 multiplied by 10 divided by 2? Will this be equal to 16 divided by 2 multiplied by 10 divided by 2? I'm sorry, not multiplied. Wait a minute. Made a mistake here. This should be plus. Okay. If I do this, will this hold true?
No.
It won't be true. 16 plus 10 whole divided by 2 is equal to 16 by 2 plus 10 by 2. This won't be true.
Yeah, it will be true.
It will be true.
Yeah.
Okay. So can we say the distributive property is true for multiplication and for division?
Yeah.
Can we say that? Yeah, okay. Just a minute. All right. So it holds true for multiplication and division. All right. Next.
Associative properties. Associative properties are like groups. For example, minus 3 multiplied minus 2 minus 3 multiplied minus 2 multiplied 5.
Okay, then.
And minus 3 multiplied minus 2 multiplied 5.
What's the difference in these?
In the first one, minus 3 and minus 2 are in groups.
Okay. And the second one?
Minus 2 and minus 2 and 5 is in group.
Yeah, okay. So this is true for, you said this is true for multiplication. And what else is it, does it hold for?
Addition.
Very good. So it holds for addition and multiplication. Okay, next.
Can you tell me how it holds for addition?
Okay, how it holds for addition? How about 5 plus 3 plus minus 6? Okay. And then that will be equal to 5 plus 3
Bracket
plus minus 6.
plus minus 6.
Got it?
Yeah.
Okay.
Why did you put a minus 6 in brackets?
Okay, I won't put it in bracket though. There you go. I just have a habit of putting negative integers in brackets, you know. That's why. There you go. Okay.
Okay. Thank you. Okay, so the next one is closure properties of multiplication. Closure of multiplication.
What does that mean?
That is a pair of integers whose product is always an integer.
Right. So you said that it holds true for multiplication. Does it hold true for addition as well? So if I say closure for multiplication, that means that if you have any two integers any two integer. Okay, this is going to be an integer and this is another integer. If I add them, they will all, the result will, sorry, you said multiplication, right? So if I multiply them, the result will always be an integer. This is called closure. Okay, that you have integer, one integer, and the third one will also be an integer only. So, okay, this holds true for multiplication. What about addition? If
This
over
the
here,
sum
hmm,
the sum of two whole numbers
hmm.
is again a whole number.
Whole number, are we talking about whole numbers here or are we talking about integers?
Sorry, the sum of
Hmm.
two integers is again a integer.
Okay, and then what about, chalo, okay, so this is true for addition. What about, give me a sec. What about subtraction? Is it true for subtraction?
Yeah.
Can you give me an example?
7 minus 6.
7 minus 6 is again an
1.
integer. Okay,
Yeah.
just recall whole numbers. Okay, recall whole numbers. And when we were talking about whole numbers, when we were not talking about integers, we were talking about whole numbers. That time we didn't know about integers, right? Like back in 6th grade. So that time we said that the closure property holds for addition of whole numbers. So if you're talking about whole numbers, we said that the closure property holds for addition, right? Because when you add two whole numbers, it's going to give you a whole number always. But back then, did it hold for negative integers? Sorry, negative whole numbers. I'm sorry, what am I saying? Did it hold for subtraction of whole numbers? Like if you subtract two whole numbers, you have one whole number over here, one whole number over here. Okay. Did it, and if you subtract it, will it always give you a whole number? Can we say that closure holds for subtraction of whole numbers?
Yeah.
Can you tell me why?
Because after subtracting the whole numbers, you will get an
Can you give me
whole.
an example?
Yeah.
Can you give me an example where you subtract two whole numbers and you always get and you get a whole number?
12 minus 10.
Okay. Now how about I give you two whole numbers? I will give you a counter example. I am saying that this will not hold. Okay. Let me give you a counter example as to why. Sorry. How about the number 5 and the number 8? Do 5 minus 8. What is 5 minus 8?
3 minus 3.
Minus 3. 5 minus 8 is minus 3. But is it a whole number?
No.
No, it is not a whole number, right? It is an integer. Okay. So, whereas in this example, the answer was a whole number, but in this example, the answer that you're getting is not a whole number, it's an integer. So, when you subtract, okay, when you add two whole numbers, the answer will always give you a whole number. But when you subtract two whole numbers, you might get a whole number, you might not get a whole number. So that's why we will say that closure property does not hold under subtraction when it comes to whole numbers. Okay, but when it comes to integers, it does hold. Why? Because you take any two integers, even if you take, let's just take the same example over here. You take 5 minus 8, that will give you negative 3, but that is again an integer itself, right?
Yeah.
So that's why it will hold. I hope I cleared a concept for you.
Yeah.
Yeah, okay. So yeah, does closure property, so again, does it hold under addition? Yes. Does it hold under multiplication? Yes. Does it hold under subtraction?
No.
I'm talking about integers.
Yeah.
Yeah. Okay, so right now we're talking, the whole thing that we're talking about over here is integers only. We're talking about integers. Okay, so you're saying it holds under subtraction. What about
Can you
division?
can you
Huh.
explain again?
Okay, from where do you want me to explain?
The subtraction.
Okay, so closure means that you have an integer here, you have an integer here. Okay, this is, we're talking about closure under subtraction of integers. So if we put a subtraction sign, you need to have two integers, and when you subtract them, you should get an integer. Okay, you should always get an integer. So this does hold true. This is true that no matter which two integers you put, you will always get an integer. Okay, you can take any countless number of examples that you want. It will always hold true. Whereas if you were not talking about integers, if you were in sixth grade, like you were last year, if you were talking about whole numbers, then this would not have been true in whole numbers. Okay, because when you subtract two whole numbers, the answer might not always be a whole number. Like we just saw that the answer was -3, and that's not a whole number. But in the case of integers, no matter which two integers you take, the answer will always give you an integer only when it comes to subtraction or addition or multiplication. Let's see about division. Is that clear?
Yeah.
Do you want a few examples, or is it clear to you?
You can give me a few examples.
Okay. Now, you can take any number you want. It will always hold true. Like let's say 10 minus. So when we talk about subtraction, we have a few options, right? We have bigger number minus smaller number, right? Then we have smaller number minus bigger number. Then we have something like let's try 0 minus 0. Okay, so let's try the bigger number minus smaller number. So 10 minus 7, what does that give you?
3.
3. Is it an integer?
Yeah.
Yes. Okay, done. Now instead of 10 minus 3, how about let's do this one, smaller minus bigger. Okay, 15 minus 25, what is that? This is an integer, 15 is an integer, 25 is an integer. What does that give you?
10 minus 10.
Minus 10. Very good. So that is, what is it? Is it an integer? Yes or no?
Yeah.
Yes. So again, that is an integer. Okay. Let's see 0 minus 0. Is 0 an integer?
No.
0 is not an integer.
It is. Yeah, it is an integer.
It is an integer. Very good. So, okay, so this 0 is also an integer. This is also an integer. When you subtract them, what will you get?
Zero.
0. And again, 0 is an integer. So here again, we have closure property is following. Okay, over here, all we are doing is, over here also we took positive integers, positive, positive, positive. Let's try taking some negative integers. Okay. How about -6? And then we're subtracting them. -6 is an integer. And let's take a positive integer, say 2. So -6 minus 2, what does that give us? I can't hear you.
We have to add them.
Okay. We have to add 6 and 2, right? Not -6 and -2. Well, yeah, we have to add
minus 8.
Yeah. Very good. So -8. So is -8 an integer?
Yeah.
Okay, it is an integer. How
But can I
about?
ask you a doubt?
Yeah, of course.
So if the question was -6 minus -2, in that do we have to subtract or add?
Okay, let's see this. -6 minus -2. First of all, tell me what will this thing become? If I once I want to simplify it, I'm trying to simplify it. So what
Minus
will this?
6 plus 2.
Very good. Minus 6 plus 2. Now you tell me what will happen here.
6 minus 2, that's going to be minus 8. Wait, it's, sorry, 6 minus 2.
What is 6 minus 2?
4 minus 4.
Minus 4. Okay. So you understand, right, how to do this?
Yeah.
Yeah. So over here, what we are doing is, see, these are two different things, Hiba. Over here, I am subtracting minus 2 from minus 6, right? Look at the language of the expression. This is known as a mathematical expression. So look at the language. What is the language telling you? That I am subtracting. This sign is telling you that you are subtracting minus 2. Okay, you are subtracting minus 2 from what?
Minus 6.
From minus 6. What is this language? What is this expression telling you by its language?
Minus 6 plus 2.
Yeah, so over here we are adding 2 to minus 6. Did you see the difference?
Yeah.
But they are the same. Okay, they are a little different when it comes to the language, but mathematically their value is the same. Just like how we say that 5 plus 3, this looks like a different thing, the expression is different, the language is different, but if I say, so 5 plus 3 is a different thing when it comes to language, and 10 minus 2 is a different thing when it comes to language, right? We're talking about two separate things here, but their value is the same. Their value is the same. That is the difference. Did you get it?
Yeah.
Okay, so now over here, if I were to just give me a sec. Wait a minute. Yeah. So tell me, if you have minus 6 and minus 2 and you're supposed to subtract them, what will you get? What will the answer be?
Minus 4.
Very good. Minus 4? Yeah, minus 4. So minus 4. And is that an integer?
Yeah.
Yeah. So we can see in all the cases it holds true. So can we say closure holds under subtraction?
Yeah.
Yes. Now let's take a look at division, whether it holds under division or not. Can you think about it for a moment and tell me?
Minus 10 divided by 5.
Divided by 5. What is that?
Minus 2.
Minus 2. Is it an integer?
Yeah.
Okay. How about I give you two integers, Hiba? Okay. First of all, I have 5. Is that an integer?
Yeah.
I have 2. Is that an integer?
Yeah.
I am saying 5 divided by 2. Just give me one moment, Hiba. Just give me one moment. Okay, I'll go get the book. Okay. Yes, 5 divided by 2. What does that give you? 5 divided by 2.
2.
5 divided by 2 is what?
2.
Okay. What is 4 divided by 2?
2.
So can 5 divided by 2 and 4 divided by 2 be the same thing?
But 5 doesn't come in 2's table.
Yes. So see,
It's going to be
Hiba,
0.
it's going to be 0. So
Yeah.
does that mean that 2 multiplied, okay, see, Hiba, when we say that A divided by B is equal to C, what does that mean? It means that B multiplied by C will give you A. What do I mean by that? Let me just give you an example to clear things out. So when I say that 10 divided by 5 is equal to 2, or let's not take this example, let's take some other example. Yeah, okay. When I say 12 divided by 4 is equal to 3, or let's write it like this, 12 divided by 4 is equal to 3. What does that mean? That means 4 multiplied by 3 will give you what? 12, right?
12.
So just a sec. Okay. So you are saying that 5 divided by 2 is equal to 0. So that should mean that 2 multiplied by 0 should be,
5.
but is that true?
No.
No. So that means 5 divided by 2 is not 0, right?
So how are we going to do this question?
So you see, 5 divided by 2 is a number which does not come under integers. Why? Because 5 divided by 2 is equal to 2.5. Okay. Let me explain it to you this way. 5 divided by 2. So let's say you have, let's say 4 pieces of chocolate. Okay. You're supposed to divide them among 2 people, among 2 children. So one kid is gonna get 2 parts and the other kid is gonna get 2 parts, right?
Yeah.
That's what 4 divided by 2 equals 2 means. But if I say that I have, let's say 5 chocolates like this, 5 separate chocolates, and I'm supposed to divide them among 2 kids. I'm supposed to divide 5 chocolates among 2 kids. Okay. How can I do that? I'm gonna say first, well, wait. So
we will give like one chocolate to the, we will give 2 chocolates to each of them, and then the last one we will cut it in half.
Yes, mashallah, you're so smart, mashallah. Okay, so I'm dividing these two for 2 kids, and then the last one I'm gonna divide it into 2 halves. I'm gonna say, well, you take half and you take the other half. So how many chocolates is each child getting?
2.5.
Yes, 2.5. We say 2.5 or 2.5, like that. Okay, because one, this is called half, right? This is the decimal notation. So we will come to that when we're talking about the decimals wala chapter. Okay, this is the decimal notation, and this is the what am I saying? I'm sorry. This is the fraction notation, and this is the decimal notation, right?
Yeah.
Okay. So this is the same thing. Half is equal to 0.5. So where did it go? Yes. So now 5 divided by 2 is what? 2.5.
2.5.
And 2.5 is, does it come in under integers?
No.
No, it does not. So this is not an integer. In fact, this is something that comes under rational numbers, which you will look at later, but it does not come under integers. So it is not an integer. Okay. It is a different type of number. Anyway, so this does not hold true for division. Did you understand why it does not hold true?
Yeah.
Yeah, okay. So, all right. Yeah,
And
any other properties? Huh.
Yeah. Additive identity is 0.
Additive identity is 0 and
example 7 plus 0 is equal to 7.
okay. Additive
And
identity is 0.
and multiplicative identity is 1. Example
Yes.
7 multiplied by 1 is equal to 7.
Very good. Okay. Okay. Good. Did you understand all of these?
Yeah.
All right. Did you do the worksheet that was given to you? Did they give a worksheet to you?
Yeah, some questions.
Some questions were sent. Can you read them out?
Yeah. Write the opposites of the following state. Write the opposite of the
Yes.
following statement. First is
Okay.
profit of rupees 500, loss of rupees 500.
Okay, just a minute. Let me just take a look at the PDF or the thing that I said. Yeah. Okay, go ahead. Profit of rupees 500. The answer is loss of rupees 500. Very good. Okay.
70
Then,
meter below sea level.
very good.
And 30 kilometer east.
Excellent. Then,
Decrease,
yes.
rise, decrease,
Yeah, decrease
rise,
in temperature.
decrease
Okay.
in temperature.
Because increase in temperature or rise in temperature, it means the same thing. So if you say if you say decrease in temperature or drop in temperature, that is also the same thing. So increase is the opposite of decrease and rise is the opposite of drop. Is it clear?
Yeah.
That okay? Okay. All right. Then next.
45.
Okay. You have to arrange them in ascending order, right? So let me just first write the integers. Minus
Okay.
105, 73, minus 50, minus 67, and 45. Okay, go ahead.
45,
Okay, you are saying 45,
75.
75.
Sorry.
Hmm.
70. So 73, then 45.
Okay, first 73, then 45, then
Minus 50.
minus 50, then
Minus 67, and then minus 105.
okay. Okay. Hiba, what does ascending order mean?
Small to bigger.
Small to bigger. So if I say ascending order, like if I say one, if I am arranging the following numbers, wait. I'm telling you to arrange these, okay? 3, 0, 1, 5. Arrange them in ascending order, please.
5, 3, 1, 0.
Okay. Once more, what is the meaning of ascending order?
Sorry, it is small to bigger.
Smaller to bigger, right? Smaller to bigger. That means smaller number will come first or bigger number will come first?
Smaller.
So smaller will be here.
I'm always getting confused between
Yeah.
descending and ascending.
Okay. Have you ever heard of this term, Hiba? Ascending a staircase? Ascend. You
No.
ascend a staircase. Or you ascend in life, like when you say you are ascending in your career path, maybe. So that means you are
Yeah.
growing, you are going upwards, you are going towards the towards bigger and bigger things. So you started small and you are going towards bigger and bigger things. So that is what ascending means. That even when they say I am ascending the staircase right now, so that means I'm going up the staircase. If you say I am descending the staircase right now, that means you're going down the staircase. You're going from a bigger height to a smaller height. So did you understand it now?
Yeah.
It will take some time. It will take some time, but you'll get there. Okay. So yeah, now can you tell me what the order will be for this?
Yeah, minus 105
Yes, minus 105 is less than.
minus 67
Yes, is
minus
less
50
than.
minus 45 minus 45 and then
And 73. Very good, very good. Okay, next question.
I didn't understand this question.
Okay, so in this question, you're supposed to complete the pattern. So let me give you an example. If you have this pattern, 1, 2, 3, I'm giving you this much only, okay? Or let's say I'll give you one more. And you have to fill in 4 more. 1, 2, 3, 4. Now tell me what will be, or what will come in these blanks.
5 and 6 7 8
5, 6, 7, 8. You know that because you know the pattern very well. Now I give you one more example. 2, 4, 6, 8, blank, 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 blank. Now tell me.
10
You see a pattern?
12
Yes.
14 and 16.
Very good. Okay, I'm going to give you one more pattern here. 3, 6, 9, 12.
15
Hmm.
7 18
Hmm.
20 21
Yes.
23
1 minute.
24.
Very good. Okay. Um. So this you found out because you're thinking, okay, these are tables, right? But what we usually do in patterns, let me give you a few more patterns. Okay. And these don't always have to be tables. It can be anything. These are multiplication tables, right? It doesn't have to be that. Like, for example, 104, 114, 124, 134. Now tell me what will be there in the next thing.
144 154
Yes.
164 and
Best.
174.
Best. Very good. Okay. Now how about I give you this? Let's see if you can get this one. Okay. Wait. Hmm. Now tell me.
95
Hmm.
92
Nope, it's not 92.
and 94.
Nope. Okay. So first tell me on what basis are you saying this? On what basis? Come on, come on, come on. Let's think. What made you say that? What made you think that it's gonna be 94 or 96 or 92?
Because it's like 52 and 64, so I thought it's going to be 92 and 104.
Okay. But how do you know that over here it's gonna be 2? Why not something else? How do you know that it's going to start from this from over here itself? Let's take a look at it from another perspective. Okay. Uh, how did you notice the pattern in all of these? What pattern did you notice?
The last number.
Okay, so you said the last number is the same and the first number is the same. 1 and 4 are the same. All that is changing is from 0, it became 1, then 2, then 3, and then 4, and so on. If I told you what I'm actually doing over here, what I actually did, I said 104, then I added 10 to it. Okay, then I got 114. Then to that again I added 10. Then I got 124. Again I added 10. I got 134. So that was the pattern. So can you tell me what is the pattern in here? What you need to do is see what should I add to the first number
11.
to get the second number. 11?
Yeah.
What is 52 plus 11? Just confirming.
Sorry, 12.
Yes, it was 12. So I added 12. Okay. So let's just see whether our thinking that this is the pattern is right or not. So what you need to do once you have once you have made a guess that okay, it's probably 12. So what you need to do now is start adding 12 to every number. Okay, add 12 to this and see whether or not you are getting this.
Okay.
If you add 12 to 64, are you getting 76?
Yeah.
Yes, 76. If you add 12 to 76 again, are you getting 88?
Yeah.
Yes. So now what do you have to do?
Add 12 to 88.
Add 12 to 88. What will you get?
100.
100. Very good. Then you add 12 to that. What will you get?
112.
Very good. Then you add 12 to that. What will you get?
124.
Very good. Okay. So now do you think you can do the patterns?
Yeah.
Tell me.
Minus, sorry, 5.
Yes, very good. So the thing was 25, 20, oops. Okay, 15, 10. Excuse me for the handwriting. Huh. Then you're saying 5, then oops.
Minus 5.
Wait a minute. So what are we doing each turn? What are we doing? We are subtracting 5.
Yeah.
Is that true? So if we are subtracting 5, from 5, what do we get? Do we get minus 5?
No, 0.
We get 0. So first you will write 0, then
Minus 5.
minus 5, then
Minus 10.
minus 10. Excellent. So let's keep it till there itself. Okay. Next pattern.
Minus, minus 4.
Okay, you're saying minus 4. First, let us recognize the pattern. What is the pattern?
Sorry, minus 3.
Yes, excellent. So it's going to be minus 3 and then?
Minus, sorry, 0. Just 0.
0. Okay, then?
Minus 3. Sorry,
Again minus 3.
3.
Positive 3. Very good. Then?
Positive 6.
6. So what was the pattern that you recognized here?
3.
We are adding 3, right? Excellent, excellent. So you're getting better at this, mashallah. Next. We have minus 32, minus 28, minus 24, minus 20. Then?
Wait. Minus 16.
Okay, minus 16. Very good.
Minus 3.
Minus 3.
Sorry. Minus 13.
Minus 13. Are you sure?
Yeah. Sorry.
You sure?
Minus 12.
Yes, it will be minus 12. Very good. Next.
Minus 9.
Hmm, minus
Sorry.
9.
Minus.
Okay, wait.
So,
Hiba,
minus
first,
8.
tell me what is the pattern that you recognized here?
4. We are adding 4.
Adding
Then we are
4.
subtracting.
Nope, you are adding 4.
Okay.
Right? You are adding 4. So you keep adding 4. Then minus 12. Then you add 4 to minus 12. What do you get?
Minus 8.
Very good. Minus 8. Then one more.
Minus 4.
Minus 4. Okay, give me 2 more.
Minus 1. 0.
0.
And
Then
positive 4.
positive 4. And then it will go on where? What will it be? Just tell me verbally. Positive 4, then?
Positive 8.
Then?
Positive 12.
Yes. Next?
For positive 14. Sorry.
14.
Positive 16.
16. Okay. Positive 16. Then?
20.
Positive 20. Then?
24.
Okay. Positive 24. Then?
28.
28. Okay, so you see that it's going like, it's a pattern, so it will continue the same way in the positive as well, positive direction as well. Okay, very good. So now let's take a look at the other questions. Yeah. Yeah.
Can I go drink some water? And then I
Yeah,
will.
sure. Yeah, yeah. Okay.
I'm back.
Okay. Yes. So the next question.
1,003.
Hmm?
1,300.
Okay, let me just write the question. A submarine is positioned 1,300 meters below sea level. So this is, if this is my imaginary number line, okay, and my sea level is right over here. This is my 0, and my submarine is positioned 1,300 meters below the sea level. So it's negative 1,300. My submarine is over here. Okay, if it ascends 450 meters, what is its new position? So what is the answer?
1,300 minus
Okay,
minus 450.
minus 450, 1,300 minus 450.
Yeah.
What is the answer?
Is it going to be subtraction?
Yes, you're right. It will be subtraction.
Okay.
Hmm.
So 850
Yes, 850 meters. But will
meters.
it be 850 meters below sea level or above sea level?
Below.
Below sea level. Okay, Hiba, here is something I'm going to tell you, which might be of some help. See, if I'm talking about above sea level, below sea level, okay. If I say positive 850 meters, what does this mean? What does it mean? It means 850 meters above
Above.
sea level. Okay. Let me just highlight this above sea level part. Okay. And if I say it is negative 850 meters, what does that mean? Yes, Heba?
It 850 below sea level.
Meters below sea level, right?
Meters below sea level.
Oops. Below sea level. So just learn to recognize the meaning of the positive and the negative sign. Okay. Now, Hiba, if you want to say that something is, let's say, 20 meters below sea level, okay, and without writing it in English words, without writing, above sea level, below sea level, if you just want to mention, if you just want to let people know that something is 20 meters below sea level, you will
Minus
say,
20.
yes, that the position of that object is dash minus 20 meters. Okay. So that is why I began by writing minus 1300 meters. So the way you have done it is not wrong. Let me just write it like this. The way you have done it is, okay? This is the way you've done it. 1300 minus 450 meters. So that's 850 meters below sea level. But the way I would rather do it, and I think this is the more mathematical way of doing it, is that you will say the position, the position of the submarine is what? What is the position of the submarine?
850.
No. The starting
About
position.
1300.
Is it positive 1000 or negative 1000?
Positive.
No. It is a submarine is positioned 1300 meters below sea level. So now tell me
Minus.
below. Yes. So it is negative 1300 meters. That is the position. Now you don't have to write above or below. Why? Because your negative sign is doing that function for you.
Okay.
Okay.
If
So
we have to write above sea level, we have to write positive 1300.
yes, exactly. Okay. So the position of the submarine is negative 1300 meters. Clear?
Yeah.
That is the initial where it started. Now it is going up. It is ascending. Now, as I told you, remember, ascending means what? Going up. So it ascends 450 meters. So when it is ascending, that means you have to add it, right?
Yeah.
Yeah. So what you will do is, what will you do now? You will add what with what?
450.
Yeah, you will add that to
1300.
will you add that to 1300 or negative 1300?
Negative.
Negative 1300. Okay. Why? Because it is ascending. So you will add it to negative 1300. I am just thinking of it from this perspective, that my sub was over here. Okay, it is ascending, so it is going in this direction. It is going in this direction, and it reached it reached this spot. Okay, it reached this spot. That's why I'm adding. Like, remember, if we are talking about a number line, and if you are like over here and you want to go to the positive thing, so you add, right? You want to go towards the positive side, you want to go towards less negative, then you add it, you add a positive number, remember?
Yeah.
Yeah, so you're going to the right side, so you do addition. We say when we're going to the right side, we do addition. So this is the thing that I've used over here. Okay, so negative 1300 plus 450 will give you, what will it give you?
1300 minus 450.
No, that will be something that you will write in your rough column. So now do this calculation in your rough column and tell me.
Minus 850.
Very good. Minus 850 meters. That's it. That's all you'll write. Because of the negative sign, you don't have to write minus or plus. Okay.
Yeah.
If you write plus 850 meters, then that will automatically mean it is above sea level. But since this is below sea level, you will write negative. So are you seeing how your answer and my answer are the same, but we have written it in different languages?
Yeah.
Yeah. So it's the same thing. What you have done is that you have taken 1300, that was the depth, and you have subtracted 450 from it. You have subtracted that much distance. Like you have said, it's becoming closer and closer to the sea level. So you are subtracting the distance. That is also fine. Okay. But if you're doing it this way, then it becomes this. So that they're both the same. Are you understanding how they are both the same?
Yeah.
Yeah, very good. So do you want to complete the rest of the answers now, or should we do them later, or should we like keep on continuing the class until the next student comes?
No, I have to study for the exam tomorrow.
Oh, you have an exam tomorrow. Which one?
Hindi.
Oh, you have Hindi exam. Okay, all the best. And when's your math test?
It's on 30 June.
It's on 30 June.
Yeah,
Okay.
after
So
that we have vacation. It's
after
the last.
that you have vacation. Oh, okay, that's great. And when is your school reopening?
It's going to reopen in September something, like 1st or 6th.
Okay, it's gonna open in September. So like the whole of July and August is your vacation, right?
Yeah.
Okay. Hiba, what do you say we prepone our timings, our class timings, like by 1 hour because of your like during your vacation? Will that be okay?
Yeah.
Yeah. So what time would you be comfortable for the classes?
The same time.
The same timing as we're having right now, or do you want to shift the timings?
No, it is okay.
This is
wait,
okay?
are you talking about like in summer vacation?
Yes, only in summer vacation because you don't have school, right?
Yeah.
Yeah.
Okay, we can do that.
You can do that. So just tell me the final timing.
I will tell you in WhatsApp.
Okay, yeah, sure. Just let me know. And one more thing. You said your midterm exam is on 18th July, right?
Yeah, it is on 9. It is in 19.
Okay, it's on 19th July. So your midterm exam is on 19th July, and the syllabus are, I think, 4-5 chapters.
Wait, we don't have like exams in July.
You don't have it exactly. So you have vacations in July, right? So
Yeah.
what is your syllabus for this test on 13th June?
The first 3 chapters and the 15th chapter.
Chapter 1, 2, 3, and 15, right?
Yeah, but in the 15th chapter, only like 1 and 2 exercises are coming, not the whole chapter.
Okay, only first and second exercise. All right. So Hiba, we are on the first chapter. We have completed the first chapter. So in the next class, we will start the second chapter. I will give you some homework for the second chapter itself, like not exactly homework, it's like a pre-class activity. Okay, so you'll do that and we'll discuss the answers in the
Wait,
class.
in the third chapter,
Yeah.
exercise 1 and 2 are there, but the 15th chapter, the whole thing is covered.
Okay. In the third chapter, right?
Yeah.
All right. Okay. So